are going to attempt MCQs questions. There are 50 MCQs questions that I am going to do. So first of all, in which of the following liquids do the intermolecular force include dipole-dipole force exist? So first of all, dipole-dipole force exists only in polar molecules. So if it exists in polar molecules like fluorine is FF, fluorine is having the same atoms on both sides, which makes them a non-polar molecule. And CH4, which is going to be the non-symmetrical is the one in which central atom is carbon and the surrounding atoms are hydrogen and hydrogen. So you can see surrounding atoms are different while it doesn't have lone pair as well. So we can say CH4 is a non-symmetrical, which is a non-polar molecule. CF4 in the same way is also going to be non-symmetrical because surrounding atoms are same. So that is also going to be non-polar. While if you see CH2F2, that is the only molecule which is going to have dipole-dipole force, because as it is a symmetrical molecule, surrounding atoms are not same. Central atom is carbon, surrounding atom is hydrogen, fluorine. So it's not same, so our answer is going to be D. Next question, which of the following best explains why an increase in temperature result in increase in the rate of reaction? So when the temperature is increased, then what happens? Kinetic energy of particles also increased, which because of that the number of collisions increase. So let's see the options now. At high temperature, reaction have lower kinetic activation energy. Wrong, because lower activation energy is only linked with the catalyst, that is only linked with the use of catalyst. Then at high temperature, reaction have higher activation energy. Wrong. Temperature has nothing to do with the activation energy, so this point is wrong. At high temperature, every collision result in the formation of product. Absolutely wrong, because only those collisions will be result in the formation of product in which the particles energy would be equal to activation energy. Only those collisions would result in the formation of product. But what happens at high temperature, high energy collisions happen more frequently. That's absolutely correct. Next question, a sample of hard, solid, binary compounds at room temperature did not conduct electricity as a pure solid but become highly conductive when dissolved in water. Why? Because in the ionic compound, guys, like for example NaCl is an ionic compound, and when it is dissolved in aqueous form, then what happens? It is going to be split up into ions. So you can see that there is going to be availability of free moving ions. There will be free moving ions there. So because of the presence of free moving ions, ionic compound can conduct electricity. So because of presence of free moving ions, so ionic compound can conduct electricity in molten and in aqueous form. So answer is going to be A. Now they are saying NH3 was synthesized at 200 degrees Celsius in the presence of a powdered catalyst leading to the equilibrium represented above. Which of the following changes would result in more NH3 in the mixture after equilibrium is re-established? So they are saying the reaction is exothermic, if you see the reaction is exothermic in forward direction. And if you want the reaction to move in the forward direction, because they want us that how more NH3 would be produced, definitely the reaction has to move in the forward direction. That can be achieved in what ways? Like either you increase the quantity of N2, either you increase the quantity of H2, then according to Lee-Chattrell principle, the equilibrium will shift towards right hand side. Okay, and the second thing, like here you can see the option is there that adding some N2 would shift the equilibrium towards right hand side and more amount of NH3 would be produced. And if they would be asking about, so now they are saying which of the following arrange the molecules N2, O2 and F2 in order of their bond enthalpies. Bond enthalpy is the energy required to break a bond. Energy required to break a bond. And guys, one thing here, there we have three: fluorine, oxygen and N2. Fluorine belongs from group 7 having single bond, oxygen from group 6 having double bond, nitrogen from group 5 having triple bond. So remember, nitrogen is called an inert gas. Why? Because it is having triple bond, it is having quite high bond enthalpy, it is very difficult to break. So which is going to be the right option for us? That is going to be A. So for the next question, they are saying a 23-gram sample of a compound contains 12 gram of carbon, 3 gram of hydrogen, 8 gram of oxygen. Which of the following is the empirical formula of the compound? So we have carbon there, and then we have hydrogen, and then we have oxygen. Carbon is 12 gram, hydrogen is 3 gram and oxygen is 8 gram. So first you need to find the number of moles by dividing with the molar mass. So that is 12, that is 1, and oxygen is 16. So it comes out to be 1:3:0.5. And for the moles, we have to divide with the least number of moles. So least number of moles is 0.5. So the answer comes out to be 1:6:1. So it is 2:6:1. So the answer is going to be B. So first we have divided with the molar mass. Second, we are going to divide with the least number of moles. Then we have got the ratio 2:6:1. So for the next question, based on the Ksp value, Ksp is the solubility product, and it tells you that how much a particular substance is soluble in water. That tells you how much a salt is soluble in water. So the greatest quantity that you are having among this compound is of Ksp, which is for PbCl2, which is having the greatest quantity, which is 1.2 times 10 to the power minus 5, which shows that it is going to have the greatest solubility. If greatest solubility, that means PbCl2 is in solid state. When it is going to have the greatest solubility, then it is going to form more amount of chloride ion, the highest chloride ion, as it is having the highest Ksp value. So the chloride ion production will also be the highest. So our answer is going to be A. For the next question, they have given the distribution of speed of H2 molecule at 273 Kelvin and 1 atm is shown in the diagram above. Which of the following best shows the speed distribution of He atom under the same condition of temperature and pressure? So we need to see for He atom, He is helium and it is having the molar mass of 4, H2 is having the molar mass of 2 because hydrogen is having 1, so H2 is having 2 there. So what happens, you can see which of the following best shows the speed of helium. Helium is having greater molar mass. So we know speed of something is inversely proportional to the mr. So helium having the greatest mr would have the lowest speed. So this straight line that represents the speed of hydrogen. So the right answer is going to be A option. Why A option? Because if you see, this represents the helium, but when the you can say when the mass has been reduced, then the speed needs to be increased. So this is going to be the speed of hydrogen that has been increased as the molar mass becomes 2 there. And now for the next question, question 14 to 15, what they are saying to us, 2H2O2 in aqueous form is forming 2 water molecules in liquid plus O2 in gas. The equation and stated cell potential for the decomposition of H2O2 in acidic condition at 25 degrees Celsius is given below. The reduction half reaction for the process are listed below. So this is the main equation, and this equation has to be transformed to form this equation. And we have to transform these two equations to make this equation. So this equation will remain like this, okay, because there are 2H2O liquid and 2H2O liquid are on the right hand side. So we are going to keep this equation the same way. But if you see second equation, H2O2 needs to be on the left hand side. So we need to reverse this equation, reverse it and multiply by 2 to balance the number of moles. So we need to reverse it, so it becomes 2H2O2 and it would going to become 2O2 gas state plus 4 hydrogen ions in aqueous form plus 4 electron. So if you see that if you are going to add this equation 1 and equation 2, you are going to have this equation 3. So we can say 1 plus 2, that becomes 3. Now, which equation represent oxidation and which represent reduction? So this is going to be reduction. Why this is reduction? Because addition of electrons are on the left hand side, and here the electrons are on the right hand side, so this represents oxidation. This represents oxidation. We know a formula that is NOx. Oxidation take place at anode, and red cat means reduction take place at cathode. So guys, now E naught of cell is equal to E naught of cathode minus E naught of anode. So cathode is where cathode is going to be, E naught of cell has been given to us 0.55. Cathode is going to be 1.23 volts, and this we need to find out. So if we are going to solve it, E naught of anode goes on other side, 1.23 minus 0.55, and our answer that comes out to be is 0.68 volts. So answer is going to be C. Which of the following is true for the decomposition of H2O2? So for the decomposition, the reaction has to be moved towards forward direction. And if the reaction has to move in the forward direction, that means there is going to be more products than reactants. As you know, K equilibrium is equal to the concentration of product over reactant. So if we want more product, because why we want more product? Because we want the decomposition of H2O2, so we want more product there. So K equilibrium needs to be greater than 1. When there are more product, K equilibrium needs to be greater than 1. And if we are going to say that the reaction is favorable, of course the reaction is favorable, that's why it has to move in the forward direction, then delta G needs to be smaller than 0, because it represents that the reaction is favorable. So our right answer is going to be, that's going to be C. So for the next question, they are saying which of the following will most likely increase the rate of reaction represented above. So first of all, rate of reaction can be increased. So rate of reaction that is dependent on certain factor, that is going to be like increasing pressure for gases, increasing pressure that is for gases, or increasing temperature. Because what happens when you are increasing pressure, the particles would come closer together, and in the fact that they are going to have more number of collisions, and that would result in increase in the rate of reaction. And when you are increasing temperature, then the particles kinetic energy would be increased, and hence they are going to have more number of collisions. Or you can even the use of catalyst as well, because with the use of catalyst what happens, activation energy decreased. So decreasing the temperature, that is absolutely wrong. Adding a heterogeneous catalyst, that is going to be the right answer. Why? Because heterogeneous catalyst is the one which is having different phase with the reactant. Like for example, you can see they are both are in gas phase, so the catalyst which is going to be used here is going to be platinum, which is going to be in solid state. Okay, so for next question, which of the following molecule is least soluble in water? So the molecule which is least soluble in water, that must need to be non-polar, and that is also going to be, you can say, that does not develop hydrogen bonding with water. There are two conditions. So guys, if you see question 1, that can develop hydrogen bonding. Why? Because there is a lone pair on oxygens, you can see. So it is can develop hydrogen bond with water there. This is partial negative, partial positive, partial positive. So it can develop with it. So the P option is going to be the right one. Why? Because that is non-polar. That is non-polar. What is the condition? Why it's non-polar? Because the central atom, if you see, does not have lone pair. So central atom has no lone pairs, and surrounding atoms are same. Surrounding atom are same. So that is going to be B. At room temperature, I2 is a molecular solid. Which of the following provides the characteristics of I2 with correct explanation? So first one, it has a high melting point because it has weak intermolecular force. So first of all, I2 is a non-metal and it forms a covalent bond, and it is going to have simple molecular structure. So simple molecular structure is there, and you can see it has make a single covalent bond. And I2, if you are going to discuss, like for example I2 is having weak intermolecular, that is having weak intermolecular force of attraction. So weak intermolecular force of attraction, what we mean by that? Why it is having weak intermolecular force of attraction? Because it is having London dispersion force. You can see this is I2, and what happens, it develops induced dipole force. Induced dipole force is when you are having more electron on one side for an instant of time and less electron on other side. So less electron here, partial positive charge, so force of attraction is there. More electron would be at this point, partial negative charge. So this is going to be induced dipole force of attraction. Induced dipole, because that has been induced for short period of time, and that is going to be weaker. That's going to be weaker first of all. So if that is going to be weaker, so they are saying definitely it has weak intermolecular force of attraction, but that needs to be low as well, low melting point. It is hard, it is like not hard, it is soft because it forms a three-dimensional covalent network. No. So first of all, it doesn't form a three-dimensional covalent network. The three-dimensional covalent network is only silicon dioxide, diamond and graphite are having. So now moving towards the next question, like C part, it is not a good conductor of electricity because its valence electrons are localized in bonding and non-bonding pairs. So this is absolutely correct. It doesn't conduct electricity because if you see the structure of iodine, that's going to be like this. That's going to be like this. And if you see that its electron, this is indulged in bonding pairs, that is bonding pair, and the other ones are going to be non-bonding. Okay, so that's why option C is going to be the right one. Let's move towards question number 19. Based on the information in the table above, which liquid CS2 or CCl4 has the higher equilibrium vapor pressure at 25 degrees Celsius and why? So just remember one thing, if you are having higher vapor pressure means the boiling point is going to be low. Okay, so basically vapor pressure is inversely proportional to the boiling point. So higher vapor pressure means you can easily be converted into vapor state, so that means the boiling point would be lower. So the lower is going to have the higher vapor pressure, and the one which is going to be have the higher boiling point, that is going to have low vapor pressure. So now what they are saying, like if you see option like option B, then you are going to see one thing, CS2 in liquid state because it has weak London dispersion forces. That is why CS2 is going to have low boiling point and higher vapor pressure, because it is going to have weak force of attraction. So the next question, they are saying, based on the information given above, which of the following is the strongest acid? So if you see, that is going to be an acid, that is a base, and that is going to be the, this is going to be the conjugate base, and that's going to be the conjugate acid. So we have two acids there, but if you see equilibrium, K equilibrium, that is greater than 1, that means more product will be there. So if more product will be there, that means it dissociates more, okay, which makes it a stronger acid. Stronger acid is the one which dissociates more when is dissolved in water. So our right answer is going to be A. In the next question, we have a reaction which is precipitation reaction. precipitation reaction that forms insoluble salt, which is AgCl. So when two soluble salts which are mixed, they form one insoluble salt and other is a soluble salt. A student performed an analysis to determine the amount of AgNO3 in a solution. Excess NaCl was added to the solution Ag plus aqueous ions. They precipitates to form AgCl. The precipitate was collected by a gravity filtration and dried it in an oven. So what happens when these precipitates are formed? They are going to pass through filtration and you are getting AgCl precipitates at top and you are getting NaNO3 at bottom. We have this NaNO3 aqueous solution. Then what happens? 3 trials were performed and in each case, according to the instructor, the mass of precipitate recovered was 5% higher than the actual mass of AgCl that should have formed. So they are saying it was having 5% higher mass. What is the reason? So after AgCl precipitates have been formed, they need to be washed. They need to be washed with water so that if there is any content of any NO3 salt on them, they would be removed. So because of the presence of any NO3, we need to wash them. Wash with water. So why it is going to have higher mass? Because they are not washed and the quantity of NaNO3 is over there. So option D is going to be the right one, which is saying the precipitate was not rinsed with deionized water before drying. In the next question, they are saying NaOH, HCl and NaCl, they are reacting to form NaCl and water. To determine the concentration of NaOH solution, a student titrated a 50 ml sample with 0.1 molar HCl. The reaction is represented by an equation above. The titration is monitored using a pH meter and the experimental results are plotted in a graph below. At the point R on pH curve, which is basically known as equivalence point, that is equivalence point, and what happens here, equal amount of acid and base they react. Of acid and base they react. So what happens here? Which of the following ions are present in the reaction mixture at a concentration greater than 0.01 molar solution? If you have their ionic equation, then Na plus aqueous plus OH minus aqueous would react with hydrogen ion aqueous and plus chloride ion aqueous. They would form Na plus aqueous plus Cl minus aqueous plus water in liquid form. Then what happens, from both sides they would be cancelled and would react to form H positive aqueous plus OH minus aqueous, and they are going to form water in liquid form. So the titration is monitored using a pH meter, and you can see here that at this place, when the acid and base they react, so then we are only available with these spectator ions Na positive and Cl minus at this point, because they have reacted to form water. So we are only left at this point with Na positive and Cl negative. So our answer is going to be A. One student titrated with NaOH with 1 molar HCl. So now you can see the concentration of HCl has been increased. So if the concentration of HCl has been increased there, then what happens? This equivalence point would move downwards at this point. So if you see option D, they are saying the pH far beyond the equivalence point would be lower than in the original value, because acid is more concentrated, which caused the pH to be decreased. So pH would go below than 7. So our right answer is going to be D. So the next question, a student conducted an experiment to determine the enthalpy of reaction for the reaction between HCl and NaOH. The student ran two trials using the volume of HCl and NaOH indicated in the table above to determine the amount of heat released. Which of the following best explain the relationship between X and Y? So if you want to see the relationship between X and Y, you are going to first find out the number of moles in first trial and then in the second trial. So for first trial, if you see, the moles of HCl are 0.05 times 0.1, that is 0.005, and for moles of NaOH, that is also 0.005. So both are limiting reactant, okay, and if both are limiting, then what happens, as there is 1:1 between NaOH, HCl and water, so water will also be 0.0050 mole of water for sure. Now for the trial 2, so if you see trial 2, mole of HCl, as you know, concentration has been increased, so moles of HCl, that comes out to be this one, and the moles of NaOH, that comes out to be 0.005. As this is going to be the limiting reactant, so that would also be producing 0.001 mole of water. They were producing the same amount of moles of water. So what we can say here, that because the number of moles of acid and base reacting with each other is the same in both trials, so we are going to say Y is equal to X. Because in second reaction, HCl is a limiting reactant. So that limiting reactant, that controls the amount of product which is for water. So that would also be producing the same moles of water. Okay. That would limiting is not HCl, sorry, limiting it's not HCl, limiting is NaOH there, because it is having less number of moles. So limiting here is also NaOH, because that is having the least number of moles, and that controls the amount of product, so it would also be producing 0.005 mole of water. So amount of heat release, that is dependent on Q by N, and as it is released, so it's going to be negative. So if here is the mole of water, so mole of water is same for both of them, so you can say Y is equal to X, because the number of moles of acid and base reacting with each other is the same in both trials. A student mixes a 10 milliliter sample of 1.0 molarity NaOH with 10 ml sample of 1.0 molar HCl in a polystyrene container. The temperature of the solution before mixing was 20 degrees Celsius. If the final temperature of the mixture is 26 degrees Celsius, what is the experimental value of enthalpy of reaction? So first of all, we need to find the total volume. Total volume is of NaOH and HCl, that comes out to be 10 plus 10, that comes out to be 20 milliliter, and density they have given us 1.0 gram per milliliter, and density is equal to mass per unit volume, and mass, we need to find out the mass, density times volume, so that is going to be 20 times 1, and that comes out to be 20 gram. So delta T is going to be equal to how much? Final temperature minus initial temperature. Final is 26 minus initial is 20, that comes out to be 6 degrees Celsius, and we know Q is equal to MC delta T, and M is how much? That is 20 gram. Specific heat capacity is 4.2, delta T is how much? That is going to be 6 degrees Celsius. So our final answer that comes out to be is 504 joules. Enthalpy is equal to Q by N, and it is going to be negative. Why? The temperature is increased, the reaction is exothermic. So heat released by reaction is equal to heat gained by solution. And then we have to, enthalpy is basically in kilojoules per mole. So we have to first convert this 504 into kilojoules. That is going to be divided by 1000, so it comes out to be 0.504 kilojoules divided by, we have the number of moles, that is going to come out, we have calculated the mass, and for mole is equal to mole of NaOH or mole of HCl, they are same. So what can we do? We can do one thing, mole is equal to concentration times volume. Concentration is how much there, that is going to be 1 for each one of them, so 1 mole per liter, and the volume here is going to be 0.01 liter, and that comes out to be 0.01 mole. So it is going to be 0.01 mole, and there is a negative sign there, so it comes out to be minus 50.4 kilojoules per mole. So that is going to be A. The rate law for the reaction represented by the equation above is rate is equal to K concentration of NO2 times F2. Which of the following could be the first elementary step of a two-step mechanism? So first of all, this rate equation, that is coming from a slow step reaction, because slow step reaction is going to be the one which defines the rate equation. So it must need to contain NO2 and F2, and the concentration, like the number of moles, should be 1 each, because there is nothing at the power. So the right option is going to be B. Why B? Because it has 1 mole and 1 mole which are forming NO2F plus F. So that is going to be the right answer, because the rate equation should contains, like, that is coming from the slow step reaction, and they want us which of the following could be the first elementary step of a step mechanism of the reaction if the first step is slow. So see, they want the slow step reaction, and that determines the rate equation, so it must includes in the equation as well. So NO2 is having 1 mole and F2 is having 1 mole as well. So next question, which of the following Lewis electron dot diagram represent the molecules that contains the smallest bond angle? So this is going to be S, sp, sp2, and that is sp3. So sp3 is having the bond angle of 109.5, and this is S, this is sp, sp2, and that is sp3 with a bond angle of 109.5, and due to the lone pair repulsion it would be decreased by minus 2.5, and the answer comes out to be 107. And this is going to be S, sp, sp2. sp2 is having the bond angle of 120 degree. This is S, sp, and sp2 having the bond angle of 120 degree, but with bond pair repulsion minus 2.5 would come out to be 107.5. So right answer is going to be B. A mixture containing equal number of moles of ethyl acetate and butyl acetate was separated using distillation. So in distillation, first of all, you need to understand that about the process, like what happens in distillation. Like, a tube is passing from here and there is a condenser afterwards. So you need to understand one thing. If there are two liquids, let's say we have A plus B, so the liquid which has the lower boiling point will first travel upwards. So if A, let's say, has the low boiling liquid, so that travel first upward. So if that travel first upward, then what happens? Like the one which is having the low boiling will travel first upward. So in the question, what they are saying, which of the following identifies the substance would be initially present in higher concentration? Initially means the one which is going to have the low boiling point would be present initially in most of the quantity. So the one which is having the low boiling liquid would be present initially at the higher quantity, because when distillation starts, then it would evaporate first. So what happens in both of them, we need to find the low boiling liquid. So low boiling liquid, if you say, is going to be ethyl acetate, because you can say that as there are like carbon, how many carbons are there? There are 3 carbons, okay, and like 4 carbons, we have 4 carbons. Hydrogen we have 1 2 3 4 5 6 7 8, and we have oxygen which is 2. But here if you see, we have longer carbon chain, so we are going to say ethyl acetate, because this is going to be the right answer. Why? Because it has shorter carbon chain, because it has less number of carbons, so shorter carbon chain, and therefore it has weaker London dispersion forces. So weak intermolecular force of attraction, our answer is this, and this is the one which is present initially in most of the quantity, and later as the reaction proceeds, as the process proceeds, distillation process, it would evaporate the first. In the next question, they are saying we have the reaction between C25H30 N3 positive aqueous and OH minus as represented above is first order with respect to C25H30 N3 positive. So first of all, it is first order. A 10 milliliter sample of 0.1 molar NaOH is mixed with this solution. A 5 milliliter sample of the mixture is quickly transferred to a clean current and placed in a spectrophotometer. Now they are saying they have given us the table in which they have given us the time, along with there is the absorbance. Approximately how long did it take for 75% of initial amount of C25 H30 N3 plus to react? So if you see, initially the absorbance is 0.62, 75% of it, when like you can say around 0.15 has been left. So how much time has been taken in converting 0.62 to 0.15? That is going to be 300 seconds. So that's why our answer is 300 seconds. So in the next question, they are saying what would be the effect on the reaction rate if the solution of C25H30 N3 positive is diluted by a factor of 2. So what is happening here, you can see that the concentration is decreased. Concentration is decreased as you are diluting it. As it is first order, so first order, what happens if the concentration doubles, rate would be doubled. If the concentration, for first order, what happens, rate of reaction is directly proportional to the concentration. If the concentration doubles, rate double. If concentration is halved, rate is also halved. So if it is diluted, means the concentration is decreased, then what happens, what will happen to the reaction rate? That would also become lower. So our answer is going to be B.
I don't think so. No, don't do that. Bring everything down. See? Safer approach.
Hey, can you please call server?
If he didn't come, we go.
Yeah. So So in this question, they are saying to choose a wavelength to analyze the progress of the reaction. A student records the absorbance spectra of both C25H30 and N3 positive and C25H30 and 3OH in the range of 200 to 800 nanometer. The two spectra are presented in the graph. So first of all, we need to see their colors. Like one is having violet color and 3 positive, and other is colorless. So this is having violet color and this is colorless. So they both have different colors. So if they both have different colors, and we must need to measure the just one chemical, you need a wavelength. Why? Because there are two different colors and we need to identify one color where only one chemical absorb light, so that we can identify them. So guys, you can see one thing here. We have two range in the question, 2005 nanometer and 590 nanometer. In 205 nanometer, like this is the region where you can see one thing, that there are basically two things which are falling here, because we can see the graph of two things, this one which is for colorless and for this one which is for violet. So we can't distinguish in this area, so 205 will not be the answer. We can only identify in this region. Why in this region? Because in this region you can see that only the violet color form of the molecule will absorb significantly at this wavelength, because you can see that only violet color is absorbing in this region. So that's why our answer is going to be C. In this question, they are saying carbon monoxide and water molecules, they are reacting to produce CO2 plus H2. The value of Kc here is going to be 1.5 times 10 to the power 3, where you can say that if its value Kc is greater than 1, that means we have more product. Than reactant. So if we have more product than reactant, that means we are having more quantity of CO2 or H2. So let's see from the option. We can say the option C is correct. Why? Because it is saying carbon dioxide, which is the product, is having more concentration as compared to CO. So we can say the C is going to be the right one. So in question number 33, they are saying 1.0 liter solution of AgNO3 and PbNO3 has a silver ion concentration of 0.020 and lead ion concentration of 0.001. Now, they have given the Ksp value of Ag2SO4 and PbSO4, and they are going to say, based on the information table above, which of the following will occur. So first of all, we need to find out the value of Q. Like for Ag2SO4, you know one thing, that what happens when they dissolve, they are going to form 2Ag ion plus sulfate ions. Then what happens, Ksp is going to be equal to Ag positive, and that is having square, and then sulfate SO4 minus 2. For Ag positive concentration, they have given us, it has the concentration of 0.020. I am putting here 0.020 square, and sulfate is having the concentration of 0.001, as we are finding the value here, so we are basically finding the value of Q because KSP has already been given to us. And when we are finding the value with the given values, then we are finding basically Q because we have to compare the Q with KSP. So Q that comes out to be is 4.0 times 10 to the power minus 7, and you are going to compare this Ag2SO4Q with the KSP of Q, and you can see one thing, that this KSP is basically greater than Q. So if QSP is or Q is smaller than KSP, then what happens? We are going to have less precipitates. Okay, this means that the reaction, these solid particles will dissolve and the equilibrium will move towards right hand side, and we can say one thing like Ag2SO4 will not precipitate. Okay, because it is Q is smaller than KSP, and that's why equilibrium move towards right hand side, so we have more ions. Then for the next part, let's do the same activity for PbSO4. If I'm going to find out the value of, you can say, Q, PbSO4 forms Pb plus 2 plus sulfate minus 2. So value of Q comes out to be Pb plus 2 and SO4 minus 2. So Pb plus 2 is how much? We have given 0.001, and sulfate is 0.001 as well. So that comes out to be how much? That comes out to be 1 times 10 to the power minus 6, and Q is greater than KSP here. So for PbSO4, as Q is greater than KSP, so we can say lead sulfate will precipitate, will form PPT, precipitates. I am writing for this. So option C is going to be the right one. For the next part, this is the whole solution. You can even take the picture of it. So for the next part, question number 34, what we can write for 34, the pH of 0.01 molar HNO2 solution is in which of the following ranges? So first of all, we have HNO2 there, and they are forming H positive plus NO2 minus. HNO2 is having 0.01, it's you can say concentration, and they are forming hydrogen ion and NO2. So hydrogen ion is forming X. If it is X, as it is having 1:1, so it is also X. Ka comes out to be product is X square because they both will multiply, divided by reactant 0.01. Ka, value of Ka has been given to us, this is given, that is 4.0 times 10 to the power minus 4 multiplied by 0.01, and it is equal to X square. X square comes out to be how much? That comes out to be, like, we can just find the value of X here straight, like it comes, the answer comes out, and then we are going to take the under root, so it comes out to be 2.0 times 10 to the power minus 3, which is basically the concentration of hydrogen ion. And after that, as we want to find out pH is equal to negative log of hydrogen ion concentration negative log of 2.0 times 10 to the power minus 3, and pH finally comes out to be 2.7. So it falls between the range of 2 and 3. In the next question, they have plotted a graph of relative number of electrons versus bonding energy. So they have two different places, like X, this is X, you need to find out which element it could be, because the one is calcium ion and the other one is Ar, and they are representing the binding energy of 1s. It is having 1s2, like both are having 1s2. So now calcium ion is having how many electrons? After losing 2 electrons, it is having 18 electrons. Argon is also having 18 electrons. Now, it is giving the binding energy for 1s2. So, it is the energy required to remove electrons. As both are having the same number of electrons, but which is having the higher binding energy, you can see X is having the higher binding energy. So you can see one thing why it is having higher binding energy, because calcium is +2 and it is having higher nuclear charge, because it is having a nuclear charge of +2. So as it is having the higher nuclear charge, it is going to have higher binding energy, because nuclear charge is directly proportional, like binding energy you can say is directly proportional to nuclear charge. So if it is having the greater nuclear charge calcium, it is having the greater binding energy as compared to argon. So the answer is calcium D part. Why D part? Because they are saying calcium +2 because its nucleus has 2 more protons, because it has lost 2 electrons than the nucleus of argon has. So this is going to be the right answer. Next question, a vessel contains argon at a high pressure. Which of the following statement best helps to explain why the measured pressure is significantly greater than the pressure calculated using the ideal gas law? So what happens, as you can see, like argon is at higher pressure. So at high pressure what happens? At high pressure, particles come close together, gas particles come close together. So if they come close together, now they have more space to move around and hit the wall of container with more force. And that's why when we are increasing the pressure, particles come closer together and they can easily move around and they hit the wall with more force and oftenly. So that's why you can say, when the gas has been compressed, like argon has been compressed, particles come close together and now their whole volume becomes significant. Because in ideal gas, what is ideal gas? Like that is having no intermolecular force, and the volume of molecule is negligible as compared to total volume. So then what happens if you see option D, that the combined volume of argon atom is too large to be negligible compared with the total volume of the container? So this is going to be the right answer, because at higher pressure particles have come closer together. Now they can move around easily and they can hit the wall of container with more force, or oftenly, like the particles they have come closer together because of high pressure, and now they have volume is considerable and it's not negligible now, and they can hit the wall more frequently. So our answer is going to be D. When water is added to a mixture of Na2O2 and sulfur, a redox reaction occurs as represented by the equation below. So now they are saying, so in this question they are saying 2 trials are run using excess water. In the first trial, 7.8 gram of Na2O2 is mixed with 3.2 gram of sulfur. So first of all, what we need to do here for trial 1, I am going to find out Na2O2 moles, and that comes out to be 7.8 mass divided by molar mass, which is 78, and that is 0.1 mole. And then we have sulfur mole there, and that is 3.2 divided by 32, and that is 0.1 mole of sulfur. Now you can see that Na2O2 and sulfur, they are having 2:1 from equation. That means they have same moles. So 2 moles of Na2O2 are reacting with S moles. That means Na2O2 is a limiting reactant. Na2O2 is limiting reactant in trial 1, because 2 moles of it are utilized and 1 mole of sulfur are utilized, and they have same number of moles. In trial 2, we have to find out Na2O2 moles, that is having the same mass, so it is having the same moles, which is 0.1 mole. And sulfur now is having mass of 6.4 divided by 32, that comes out to be 0.2 mole. And now you can see that again, as you know, 2 moles of it are needed. So again, Na2O2 is a limiting reactant, So in both cases, Na2 is a limiting reactant, and it is going to form, both are 0.1, and as you know, it has a ratio of 2:1 with sulfur dioxide. So mole of SO2 will become 0.05, because 2 moles are reacting to produce 1 mole, and if it is going to be 0.1 and it is going to be 0.1, then that is going to be 0.05 mole of SO2. Now you have to multiply with the enthalpy change. And how you can do it? You can do it because enthalpy is minus 610. You can just multiply by 0.05, and the answer comes out to be 30 kilojoules. So we are going to choose option C. Why? Because Na2O2 we have seen is a limiting reactant, and the heat energy is going to be 30 kilojoules. So our right answer is going to be C. So next question, atoms of which elements are reduced in the reaction? Let's look here. Sodium is +1 here because it belongs from group 1, having the oxidation state of +1. Oxygen, when it is in hydrogen peroxide form, H2O2, it is having the oxidation state of -1. We can even find it out as well. Sodium is +1, I am putting from this, and oxygen I can take X, so 2X, because there are 2 oxygen atom equal to 0, and -2 plus 2X is equal to 0. Plus 2 plus 2x, and 2x is equal to -2, x comes out to be -1. So for oxygen is -1, sulfur is 0, it is +1 -2, and it is +1 plus 1, it is -2 oxygen, and here sulfur is +4, oxygen is -2. So now what happens here, you are going from you can see sulfur, each atom loses 4 electrons. No, because you know what it is doing, sulfur each atom So first option, they are saying sulfur each atom loses 4 electron, but they want us reduced. So when it loses 4 electrons, as it is losing because it is changing from 0 to +4, so oxidation is happening there. So that's why this option is wrong. It is not reduced. In Na2O2, each atom lose one electron. So when you are going for sodium, its oxidation state is +1. Over there is also +1. So it is neither gaining electron nor losing electron. So wrong. Oxygen in Na2, each atom gains one electron. So it was having -1 oxidation state. It is going to -2. -2. So you can see after gaining electrons, there is decrease in oxidation number. So you are going to say this is going to be the right answer, because you can see it is going from -1 to -2 and from -1 to -2 as well. So each atom is gaining one electron. So our right answer is going to be C. Which of the following statement about the thermodynamic favorability of the reaction at 298 Kelvin is correct? So you can see one thing, delta G, if delta G is equal to delta H minus T delta S, delta H is -610, T is 298, delta S is minus 0.0073, because it was in joules, we have to convert it into kilojoules every time. Then you can see one thing here, like it comes out to be -607.82. So we can say that it is thermodynamically favorable, but it has been controlled and driven by enthalpy change only. Okay, for that purpose it needs to be more negative. So we can say, because delta G is negative, it is thermodynamically favorable. So first option is going to be wrong. It can't be driven by delta S only, because delta S is negative. This would make it positive. Okay, and for the reaction to be favorable, delta G needs to be negative. So C is the only option where they are saying it is thermodynamically favorable and is driven by enthalpy change only. So bond is hydrogen plus chlorine bond is forming 2HCl. So now they are saying, based on the bond energy shown in the table above, which of the following diagram best represents the change in energy as the reaction represented below proceeds? So you know one thing, like formula for enthalpy change is energy absorbed during bond breaking. Bond breaking occurs on left hand side, okay, minus energy release during bond formation. So energy absorbed during bond breaking is hydrogen, chlorine. They are on, I can write that they are on the reactant side, and in like bonds are formed always on the product side. This is for sure. So reactant side is H2 plus Cl2, that is 430 plus 240 minus HCl. HCl is 2 moles of HCl, so I have to multiply 2 with 430, and the answer that comes out to be is minus 190 kilojoules per mole. So that means either our answer is this or either our answer is this. But which thing is going to be in high energy state? So you can see basically we have so with the negative value we can see one thing, like this is exothermic. For exothermic we know one thing, like energy of reactant is greater than energy of product. So in both of option in which we have energy of reactant which is greater, you can see in option A where energy of reactants is greater than energy of product. Next question 41 says, based on the ionization energy of element X represented in table above, which of the following is most likely to be the empirical formula of an oxide of element X? So if you see ionization energy and if you see third and fourth ionization energy, you are going to see a big gap. So because of this big difference, you can say a big jump. Why there is big jump? Because valence electron is going to have only 3 electrons, and when you want to remove the fourth electron, you have to jump from inside. So because of that, what is going to happen there, like it is going to have 3 electrons, so X is going to be plus 3, oxygen is going to be minus 2, so that comes out to be X2O3. So that is going to be C option. So for the next question, 2H2S plus CH4, they are forming CH2 plus 4H2. That means Kc is this. Kc is smaller than 1, which represents more reactant than product. If they are more reactant, so which is going to be in higher state? Of course this one and this one. But as there are 2 moles of H2S, so H2S is in more quantity, so we are going to say that is going to be the answer, because CH4 is only 1 mole. For the next question, they are saying at 1 atm a sample of ice is heated. So this is at solid, and when it is heated, you can see that the graph become constant. At this place we are having solid plus liquid, okay, and at this stage we are having liquid plus gas, while at this state we are having gas. You just need to know one thing, that during melting the temperature becomes constant. This is melting, so temperature becomes constant at that time, because heat energy is required to overcome the intermolecular force of attraction. So then what happens? They are saying what is happening to the enthalpy change. Guys, what is happening as you are moving from solid to liquid then to gas? So which is having the greater energy? Like as you are moving here, energy is increasing, energy increase. So when energy increase, the energy is absorbing, it is absorbing energy. So when you are absorbing energy, then enthalpy is going to be positive, that's going to be endothermic, okay. And as you are moving from solid to liquid to gas, entropy increase, because disorderness increase, gas particles are more dispersed, so entropy increase as well. And when entropy increase, delta S is going to be greater than 0. So what happens there? The right answer is going to be B. So next question, the reaction represented above goes in essentially to completion. Okay, so it has gone to completion, which shows that like Gibbs free energy is going to be negative and the reaction is favorable. First of all, the reaction takes place in a rigid insulated vessel that is initially at 600 Kelvin. What happens to the temperature of the contents of the vessel as the reaction occurs? As it is endothermic, you can see it is endothermic, so definitely the temperature decrease as it is endothermic. So the right answer is going to be C option, because the temperature must decrease because the reaction is endothermic. In the next question, they are saying a sample of ethanol is placed in a vessel, evacuated vessel with a pressure of P1 at 600 Kelvin. What is the final pressure in the vessel after the reaction is complete? So you can see one thing, like before it was having moles, which is N1 is equal to, let's say, 1 mole, and after the reaction has been done, N2 becomes 3 moles, because 1 mole of CH3OH are forming 3 mole of carbon monoxide and 2 moles of H2. So total are 3 moles. So if we do one thing here, like PV is equal to nRT, and P1V is equal to N1RT, and P2V is equal to N2RT. So we know one thing, like if we divide these equations, let's divide these equations. So P1 by P2 comes out to be N1 by N2, and we need to find P2. P2 is equal to P1 by N1 times with N2. So P1 is how much there? P1 we need to find out, and N1 is how much? N1 we know is 1 mole, and N2 is 3 moles. So P2 comes out to be 3P1. So that is going to be D option. What can be inferred from entropy change for the reaction at 600 Kelvin? So for the reaction at 600 Kelvin, as we know, enthalpy is positive, delta G is negative there. It is positive, first of all. So delta H minus T delta S, we know the reaction is favorable, that's why it is going to completion, so it's negative. And as we know, enthalpy is positive there, so entropy change must need to be positive to make delta G negative. Okay, entropy change must be positive. Why must be positive? Because as we know the reaction is favorable, we have already known this thing, and it needs to be must be positive for the delta G to become negative. So it is going to be C, which is saying it must be positive since delta G is negative as the reaction is favorable and delta H is positive. So the next question is saying which of the following statement about the bonds in the reactant and product is most accurate. So you can see, as enthalpy change is positive in this question, that means enthalpy change is energy absorbed during bond breaking, which is reactant. So if it is positive, then that means the energy at the reactant side must need to be greater as compared to the product side. So reactant's energy must need to be greater. So you can see that the first option, the sum of the bond enthalpies of the bond in the reactant is greater than that of the sum of bond enthalpies of the bonds in the product. So answer is going to be A. So next question, question number 48 is saying which of the following correctly ranks the 3 monoprotic acids? So guys, if you see the pH there, pH is the highest. If the pH is the highest over there, then that is going to means like it is going to be the strongest acid. But if you see next option, the pH are same, but the concentrations are different. So you can say one thing, like with the concentration, the lower concentration, the pH is same. Okay, so if it is same and with the highest concentration pH is same, then that means it is going to be the weakest, because although it is having the highest concentration but still the pH is same, so it is weakest and it remains at the medium position. So our right answer is going to be D. X is the greatest, then we have Y, then we have Z. Based on the information above and periodic trends, which of the following is the best hypothesis regarding the oxide formed by rubidium? Rubidium belongs from group 1 and it is at down the group, okay, down the group as compared to potassium. It lies somehow here. So as it is having three oxides, sodium Na2O, Na2O2 and NaO2, it is also having this much oxide, then definitely rubidium which is present below, it would also form Rb2O, Rb2O2 and RbO2 because it is belongs from group 1 and present down the group. So it has to follow the trend as well. Next question. When a student adds 30 milliliter of 1 molar HCl, so first find out the moles of HCl. Moles of HCl, that comes out to be 0.3, which is volume, times with the concentration, that comes out to be 0.03. And mole of Fe is how much? That is 0.56 divided by 56, that comes out to be 0.01, that is mole of Fe. So 0.03 mole of HCl is forming like that is 2 mole of HCl and it is reacting with 1 mole of Fe. So in this way we can find out the required moles of Fe, and required moles of Fe comes out to be 0.015 mole of Fe. So required moles of Fe, they are basically greater than available mole. Available mole of Fe are this one, available mole of Fe. Then what happened, guys? Fe is basically a limiting. Fe is limiting, and that would basically controls the amount of hydrogen which is formed. So Fe and hydrogen are having 1:1. So mole of H2 are going to be the same as Fe. So that is also going to be 0.01. Formula is mole of gas is equal to volume of gas divided by molar gas volume, which is 22.4. Volume is equal to mole times 22.4, and that is basically 0.22 liter. So our right answer is going to be D.